So welcome to this class on DAX. DAX means data analysis expression, and it is the language that Power BI uses to answer questions from your data set. Like in our case, it's going to be questions like how many customers use a discount, or questions like what's the average income of women buying electronics, and many more. Now, in one of our class, I made mention that DAX is like a smarter Excel formula. Like when you use sum in Excel, you can also use sum in DAX. But DAX is smarter because it updates calculation automatically when you filter data. So it's definitely smarter. One of the challenge with these formulas in Microsoft Excel, imagine if you filter a set of data, and you calculate the sum, right? When you filter another range, it's not going to calculate because the range now differs. The range you use for your calculation differs from the range in which you have filtered. So before we go into learning how to use DAX in Power BI, let us first import our data into Power BI. And like in our last class, we talked about several methods or channels we can get data into Power BI. And today we have our data in Microsoft Excel saved on our desktop. So let us go ahead now and import data from Excel. So we click on import data from Excel, and then we go to where we have our data saved. So if you noticed, when we entered our folder, we saw that there was no file. It said no items match your search. If you are sure you are in the right folder, all you need to do is to pick all files, okay? You can see the files. Peradventure, your file wasn't saved with the right extension. So pick all files so that you see the files available. Then click on the available file or the file you want to import, and then click on open. So our file is currently being connected. Now you can see our data, and in this preview, you can see what kind of data we have. These two buttons serve different purposes. If we want to load our data directly to Power BI, we click on load. If we want to transform our data a little more or further, we click on transform, and this takes us to Power Query. So we can transform our data in Power Query before loading our data back into Power BI. But now we just want to go ahead and load our data directly to Power BI. So we click on load. And once we click on load, our data is loaded into Power BI. You can see that this canvas changes from importing our data to building our visuals with our data. And we have three important views or three primary views that we need to understand. In the report view, you can see that that is where we build our report. But we have another view called the table view, where we can go through or peruse through our data set. You could basically see our data sets from here. Then in the model view is where you create relationships if you have more than one table. Let's go back to our table view. With the understanding of what our data or our data set is, we can understand what we really need to do. I always emphasize the need for planning before data analysis. We don't just jump into analyzing our data once we have data. We have to look through our data, ask ourselves certain questions. And in this case, we have a data set like this with customer ID, age of customer, gender of customer, income of customer, purchase category of customer, frequency of purchase, payment method, satisfaction rating, and discount used. So if we look at this data looks like a data we will want to derive insight based on consumer or customer behavior, right? So let's go into DAX building blocks. And the goal here in this section is that we want to master three core tools of DAX. And the first tool will be what? Calculated columns. What does the calculated columns do? The calculated columns add a new column to our table, okay? It adds a new column to our table. So when you look at your table, what column do you want to ask in response to the questions you have asked during your planning phase? Now, since we are on the table view, it will be easy for us to navigate along calculations. So you can see calculations here. So we have new column, okay? You can see new column. We are interested in adding a new column. So when we look at our data, we can see that we want to categorize this age, right? We want to say if you are or the customer is in a particular age bracket, that customer is an adult or the customer is a young customer. So let's basically have two categories. You can have more than two categories if you like. Let's head on to new columns. We click on new column and immediately we have our formula tab here out for us to do what? To insert our formula. And you can see a new column has been added, right? And that new column is empty. Okay, so we need to perform a set of calculations that will go into this column. And instead of having the column name as column, we will have to enter a new name. And since we want to do age grouping, we can call this age group. So we'll now say age group equal, we will be using a logical statement, the if logic here. This logical statement or logical function checks a condition and returns a value depending on whether it is true or not. So that is what if does. So we'll say if, we open our parentheses. So we want to refer to this table name. And when we do refer to the table name, we will also have to now refer to the column that we are calculating from. So our table name is consumer behavior, right? So we'll say if, open parentheses, immediately I open a single quote. If, for instance, you cannot remember your table name, at least DAX will help you with this. And you can see that we have consumer data, just as our table name is consumer data, but it helps you with the individual columns in your consumer data table. So now what our interest is age. So you can just click that and it enters that formula. So we have if, open parentheses, our table name, then our column of choice or our reference column, okay? We want to now enter the conditions, right? We have entered the column. We want to enter the conditions and we are entering that condition because we use the if function here. We'll say if this, right, is greater than, so we'll use greater than, okay? Say 30, comma, let's enter the value if true. If true, say that customer is an adult, close the quote, comma. If false, that customer is young. So in your practice, you can use any you like. So let's go ahead and close our parenthesis. So a little overview of these again. We created a new column, a calculated column, and we are doing this calculation now. Instead of having our calculated column bearing column, we decided to give it a new name. And we are using a conditional function here, the if function, to say that if the age column in our consumer behavior data table is greater than 30, or if we have any entry here in the age column of our consumer behavior data that is greater than 30, let that range be called adult. Else, let it be young. That is to say, if it's less than 30, let us call that customer young. If we hit enter, we are going to have a new column here now called age group. Let us just look at it side by side with the age column. You can see 58, right? So 58 is definitely greater than 30, and hence it is adult. When you come to the third row, you can see 18. 18 is less than 30, hence that customer is a young customer. That is the first core tool of DAX. Come back to table tools and you can see that we actually do have three core tools. We have the measures, columns, and we have the table. So we just used one now, which is the column, the calculated column. So let's use the second one. And the second one is the measure. So to create a measure, or before we create a measure, Let us understand what a measure is. A measure is a dynamic calculation that changes when you filter data. We can use measures to calculate total or average of specific columns, okay? And we are going to see how that works. To begin, let us click on new measure. We want to call our measure total customers because we want to count the total customers that we have. So say total customers equals, we want a count, right? Because come to think of it, our customers here, for instance, if we are counting the total number of customers, we'll basically be counting the total number of rows. But there is no way we can sum it, right? We can't sum. So it's better for us to use count, isn't it? So say total number of customers, we will use the function count rows. The function count rows, like I made mention earlier, will help us count the total number of rows we have. We are counting row from our table, isn't it? So we'll just go ahead and pick our table. You can see our table here, okay? Consumer behavior data. So once we enter count rows, our data table, and close the parentheses, you can see that we've calculated our total customer measure. So the third is calculated tables. Okay, so let's head back to table 2 and see how we can use calculated tables. When do we use calculated table? So calculated table creates a new table from existing table. So we have an existing table called the consumer behavior data table, isn't it? So we want to create a new table based on certain calculations we need to do. So we use calculated tables to analyze specific segments. Here, the filter function is going to help us a lot because looking at our data, we would like to determine the number of people that buy electronic based on our product purchase. So let's call this, instead of a table, let's call this electronic buyers. Let's call this electronic buyers and we'll say equals. So we want to use function filter, okay, and we want to apply this filter to our table consumer behavior data. Then we are going to be looking at the purchase category. So let us enter that consumer behavior data on the purchase category. So now we want to talk about what category we are interested in. Remember, we say electronics, right? So we'll say equals, and now electronics. So because electronics is a string, so we'll write it in quotes. And mind you, we have to write it exactly as it is spelled in that category, else we will not get the results that we want. So once that is done, we go ahead and close our parentheses. Looking at our formula again, we want to filter the consumer behavior data table, and our interest of filtering, or our interest to filter, is the purchase category. But we must state where that purchase category is domiciled, which is in our consumer behavior data table. And what part of that table are we interested in, or what part of that column purchase category are we interested in? We are interested in the electronics part, those parts or customers who purchased electronics. So that is what this expression is talking about. And once we do that, you can see that we have calculated this table, electronic buyers. So when you come to your model view, you can see now that you don't have just one table anymore. You have your original table, which is the consumer behavior data. You also have the new table you created, which is the electronic buyers. And this table have all of the headings from the previous table, but what is really critical about this table is that it's just focused on those who purchase electronics. All right, so before we begin demystifying the DAX formulas, let us look at something. You know, now we have two tables as we saw here in our model view, right? We have our new table we added, which is our calculated table, which we called electronic buyers. So if we head on to our table view, because we are here on our electronic buyer, you can see that we have every customer that purchased electronics based on our new table. Back to demystifying data analytics expressions, let us begin by looking at our goal. Our goal is to learn 4 essential DAX formulas with bonuses. The function calculate changes the focus of your calculation. How? What does it do? So calculate evaluates an expression in a modified filter context. Let's see how that works in a formula. Our focus will be on our discount, right? The discounts used. So we want to count customers, but only customers who use the discount. Let's go ahead. We will be using one of the 3 tools we talked about. And what do you think this tool will be? This one we will use for this calculation. It will be measures. So let's enter a new measure. Click new measure to enter a new measure. So we want to change this measure name to discount users. Remember, our goal was to count the customers that used discount. Okay, so let's go on. So say discount users equals. So we use the function now calculate. We open parentheses. So we now add the function we want to use, and the count function is what we want to use. So we are counting what? We are counting the customer ID, okay, in our consumer behavior data table. So we can just pick it here. Remember, it's easier. So just click and to pick it. So when we count using our customer ID, we want to filter using the discount use. So we want to count those that use discount, those that said yes. We have to close this parentheses, then we go ahead and say comma. So once we say comma, we want to now refer to that table again, which is our consumer behavior data table. And this time we want to focus on the discount used. What will be our key focus to filter? Our key focus to filter will be yes. So we'll say equals yes. Yes being a string, we have to enter it in a quote. So let's go over this again. We created a new measure called the discount user, and we are using the calculate here. So this calculate modifies the filter, okay? So we say count. We want to count, but we are counting based on the customer ID, right? And filtering that count from the discount used. And our focus will be those who used the discount. And how does it show that a person or the customer used the discount? It's showed by the word yes. So that is our new measure, and we are done with that. Let's go ahead and hit enter to calculate that new measure called discount users. The second we want to do is to use the if logic. We used it earlier, but now I will explain using a different scenario, okay? So the if logic adds logic to our formulas, basically like a decision tree, right? In this example, we want to look at the income column. It would be great if we can actually categorize this income based on a range, okay? We can basically have 2 categories, say high income and low income, right? So let's do that. If we are doing that, it's actually going to be a calculated column because we need to add something like what we did with the age group, right? So we head back to table tools and we say we need a new column. And then we get ready to enter a new column heading and the formula to calculate our new column. So let us say this will be income category, right? So we say income category will be equal to, we start with the function if, open our parenthesis. So we are saying if income, that's what we want to say. But we cannot just go ahead and type income. Income is a subset of a table, isn't it? Income is a part of a table. So since income is a part of a table, we always have to remember to refer to that table that has income as a column within it. The easiest way is just to open a single quote. When you open a single quote, you can basically see all of your column headers. So now you can see income, right? Just click on it once and you have it inserted in your formula. Let's continue the logic. Say if income is greater than, so let's use 100,000, right? If income is greater than 100,000, so we have imputed the logic. We'll say comma. Let's insert the value if true. If this logic is true, what should happen? Let's say it's a high income, so we can just use high. And remember, high is a string, is a text data, so we have to put it within a quote. Now, if that logic is true, it will return high. If not, say is less than 100,000, that means this logic is false to return low. And remember, low is also a string, so we'll have to put it this way in quotes. Let's close our parentheses and we are good to go. We go ahead and hit enter. When we hit enter, we will have a new column now called income category. Let's look at calculating, say, sum for income. So we can call it now total revenue. Let's say you want to calculate that as a revenue. You can call it total revenue, or you can call it total income, right? Since it's income, you can call it total income. But I want to show us something, and I'll make reference, right, to the function we use and how different they are, and in what situations we can use them. For that reason, I'm going to add two. So I'll be using income to give you an example for, say, total revenue. I'll use the same income to give you an example for total income, but I will show you some difference. To calculate that, we are going to enter new measures because remember, we say we want to get a single value, isn't it, whenever we use measures. Let's use this measure to get a single value, which is a sum. Let's say total revenue now, because I just want to use the sum function directly. So I'll say total revenue equals, so I'll say sum. What sum does is that sum adds all the numbers in that income column or whatever column you are using. So sum adds that. So all we need to do is just to say we want to add income, right? And we close our parentheses and we are good to go. So we hit enter, it just calculates that measure for us, which is total revenue. Remember, I'm using this because I don't want to have a duplicate measure, right? I will not be able to create two measures with the same title. That is why I'm using total revenue to differentiate between sum and SUMX. So let's create a new measure now that we want to now use SUMX. I'm going to explain that further. But now let's call this measure total income. Say equals SUMX. So what SUMX does is that it returns the sum of an expression evaluated for each row in a table. So with this explanation, you are going to see that we can further add expressions within a SUMX. So we don't just want it to sum, we want it to sum and to do other things as well. So see what happens now. Let's pick our table, okay, remember, then we'll say comma, that's our interest, and we want to sum the income, right, in this table, consumer behavior data table, and the income column. But we are not just stopping there. We want an additional expression. Let's say we want to sum these, but apply a percentage discount to this value. Say we want to apply a 10% discount. You could do this directly from this table, but if it doesn't make sense to you, let's look at this. Somebody said they didn't use a discount, but you want to apply a discount to them. It wouldn't make sense, isn't it? So we definitely need to apply this to a different table. So let's just go ahead and do this. Then I think we need to create a new table that will focus on those that did a discount. So let's use these, for instance, and give this example. Then we go ahead and do it the proper way. The proper way is for us to focus on those who use the discount. We use multiply, and we want to say we are applying a 10% discount. So we'll use 0.1. So then we close our parentheses, okay, and hit enter. When we do, what we have done is that we have gotten a total income measure that calculates the sum of the income with 10% discount applied. That is what it means. So let's go ahead and create another table so that we basically see how this was applied or how this can be applied. Okay, say you can create a new column and it will be clear to us. So let's create a new table, all right, by clicking a new table. And this table, we want to call it discount used table. Okay, so equals, remember the example we used for the calculated tables, right? So discount used equals filter, open our parentheses. We want to reference that table, our entire table, which is a consumer behavior data table, comma. Then we want to filter based on discount use column from this table, right? So open a new single quote. Let's look at count used. Okay, we'll pick discount used. And discount used, our focus will be on yes, right? And yes is a string, so we'll say yes. And then close the quote and close our parenthesis. So with this now, we will create a new table called discounts used. It will give us every characteristics that our old table had, just that it's for only those who used a discount. So we hit enter. Once we hit enter, we now have a new table, and you can see that it's only for those who used a discount. So now that we have done this, we basically can create a new column that applies 10% discounts to this. Now we are on our new table called the discount used table. So that is this table now that we have. And if you come to the model view, you are going to see now that we have actually 3 tables, okay? All right, let's go back to table view and table tools, and we want to add new column to our new table, right? And that new column will be discounts applied. Those that use discount use a 10% discount. Let's multiply that 10% by this income and now have a new column with their amounts of discounts applied. So we'll call it now discount applied equals. We just want to multiply, right? We now refer to our table, right? Open single quote. When we open a single quote, let's look at our income. We are interested in our income, and you can multiply that income by 0.1, right? And close your parentheses and hit enter. Once you multiply that, you can see that you have your discount applied, and it's 10% of what we had here. If we calculate the sum of discount applied, we are going to get a value. If we calculate the sum X of income based on this, we are still going to get the same value. So basically, that is what I'm trying to explain. So let's go ahead and you can just calculate the sum of discounts applied here as a measure, right? So remember, we are in our discount table now. We basically created 3 new tables. So we have discounts applied as a measure equals. Now we want to use sum, open parentheses. Let's open single quote. Our table is not consumer data anymore. The table we want is not a consumer data table, is the discount use table. So we are summing the discounts applied column. We can close it and hit enter. Remember, I said we cannot use the same name, so we'll have to use, let's say, discounts. We hit enter and we will be able to calculate that measure. So we have seen how sum and SUMX works. So you can try average and average X on your own. So let us now do minimum and maximum. So we'll start with the measure for minimum. Okay, so let's go to our table tools and enter new measure, and let's pick minimum. Okay, let's use minimum function. The minimum function returns the minimum value in a column. Let's call this measure minimum. We'll say minimum equals to use min. This is the function that tells us the minimum number. So it returns the smallest value. Okay. So let's go ahead and enter the address of the column. That is from our consumer data table, right? And we are interested in the income column from that table. We close our parentheses and hit enter. All right. So we can create another one now called maximum. Like maximum is just similar with the syntax for minimum. All right. Just that you'll be changing minimum for maximum. So you see our measure here, minimum, we already have that measure minimum. So let's create, say, another maximum. I'll say maximum equals to max. Max is the function for maximum that returns the largest numerical value or largest string in a column that we are looking at. So the max of our income, we close our parentheses and hit enter. You are going to see now we have the maximum measure, okay? So let us calculate average. But this time, you see we have satisfaction rating. I think this satisfaction rating will be a good scenario for us to calculate our average rating, isn't it? Let's go to table tools and new measure. And this time we can say average satisfaction, right? So I can just call it AVG satisfaction. This is equals the function average that helps us to return the average or the arithmetic mean of all the numbers in that column. And the column we want is the satisfaction rating column. And that satisfaction rating column is from our consumer behavior data. So it will be good for us to just pick it here. So that is just all. We go on to then hit enter. We have basically calculated that new measure called what? Average satisfaction. So we have our average satisfaction calculated now.